Tēnā koutou katoa, ko Simon Holdaway toko ino, te uramatua o te pukapu potaio papuri ahau, I te whare wānanga o Tamaki Makarau. Greetings everybody, my name is Simon Holdaway, I'm Head of School of Social Sciences at the University of Auckland, but today I get to be an archaeologist with my whanau interested in computers and archaeology. My title, Freedom and Revolution in Digital Archaeology, I'm going to spend the next 30 minutes or so explaining to you why I do indeed think there is freedom and revolution to be found in using digital technologies generally. To get us in the kind of frame of mind, I'm going to start with a little video back to the 80s.
Today we celebrate the first glorious anniversary of the information purification directives. We have created, for the first time in all history, a garden of pure ideology, where each worker may bloom, secure from the pests, obeying contradictory laws. Our unification of the laws is more powerful a weapon than any fleet or army on earth. We are one people. One will, one resolve, one cause. Our enemies shall talk themselves to death, and we will bury them with their own confusion. We shall prevail.
On January 24th, Apple Computer will introduce Macintosh. And you'll see why 1984 won't be like 1984.
Some of you might remember that ad, others I guess not. It dates obviously from 1984, and it was shown only once, introducing the Apple Macs. I used the ad quite recently in an obituary for my old thesis supervisor, Professor Harold Dibble, who sadly passed. And I used the ad, I guess, for a couple of reasons. One, Harold started at University of Pennsylvania in 1983, so really close to the launch of that ad. But I guess more significantly, the ad promised freedom and revolution from a kind of Orwellian-like dystopic world with the introduction of computers. And of course, Harold was really well known by this particular quantitative approach to the analysis of stone artifacts. And, of course, also in writing I guess, what was really a GIS, although I'm not sure we understood what that term meant back in the 1980s, with Shannon McFerrin. And I think I remember that he wrote that in QuickBasic. Now, we could, of course, talk about Harold's contribution to computers and archaeology. And indeed, I think that is a story that really needs to be told. But I'm not going to do that today. Instead, I'm going to move to an area where I've worked for many years, Western New South Wales and Australia, and really look, I guess, at this notion of freedom and revolution that computers brought to our work and the work of a whole bunch of my students who I'll introduce in a moment. And I guess the reason that I'm doing that is that if we look at the literature around computers and archaeology, really digital technology, I guess, in archaeology, there seems to be quite a bit of concern about what some colleagues see as the unique affordances that computers bring to archaeology. There's a concern that digital technologies provide us with a method rather than a theory. And there's also concern that a kind of deluge of data produced by a whole range of different technologies might lead to a kind of form of hyper-empiricism, as other colleagues have discussed it. And along the way really lead us into a place where we're not thinking theoretically about the significance of digital technologies. And I want to really, I guess, critique that position in this talk. The reason I'm using Western New South Wales was that this was the area I started working in, I guess, after completing a PhD with Harold. And what I saw when I visited the area was just fantastic exposures of stone artifacts, in particular some other things as well, heat retainer hearths that we'll talk a little bit about, grinding stones perhaps not so much. And you can see in the illustration all those little white white flecks there, they are indeed flagstone artefacts, most of them out of silkrete, some out of quartz, that are distributed really, really widely across Western New South Wales, really as a result of a lot of erosion that was initiated, some of it quite recently due to grazing of ungulates and things. But it's this real exposure that was so fascinating to me. And beginning in the 1980s, I spent a whole bunch of time with a whole lot of colleagues really mapping the distribution of these artefacts over really quite extensive areas. Now, we could go back to the 1980s and discuss all the technology, the ancient technology now, right? It was kind of state of the art back then. And I'm sure many of you would find it really amusing. You can see a old HP 200LX computer there and a manual Sakia total station. Yes, imagine manually focusing on the targets to use a total station. I could do that, but really it's not so much how we recorded archaeology using digital technologies that I want to focus on, but what we recorded. Really talking about those stone artifacts in particular, some of the heat-fractured stone hearths and a bunch of other, and really, I guess, the distribution of those materials across areas in Western New South Wales. Now, I want to focus on one particular area, Rutherfords Creek. It's only one of the project areas that we worked over in about, I guess, a period of about 15 years. You can see a little inset map there, Western New South Wales, for those who are not familiar with the region. There's a little square in the map of Australia there that describes more or less where it is. And the Rutherfords Creek, you can see just north of that blue lake, Perry Lake. Now, that lake actually is pretty ephemeral. It only fills with localised rainfall, as indeed the creeks do as well. And the Perry Lake also sometimes fills if the Paru River flows as kind of an overflow area. So it's a region that is semi-arid. It's characterised by quite ephemeral rainfall. Sometimes the creeks and things will fill up. Often they're dry. And as I mentioned, and you can see in the biggest slide there, the area is really characterised by these quite extensive surface erosion regions. They're called scalds locally. Scald isn't kind of hot. For archaeologists, they're really interesting because they expose thousands and thousands of artefacts that are kind of resting on the surface. Now, the interest I had in this area was that I guess I was trained in Paleolithic archaeology. I was looking at sites in the southwest of France, but these were, in a landscape sense, quite limited windows into the bigger region. I went to Western New South Wales and, like others, was really stunned, I guess, by the extent of the exposure. And like others, I'm thinking of, Harry Allen, for instance, Dan Wetter, many others who went out into this area, we saw the potential for doing quite extensive landscape archaeology. And the possibility of using surface exposures like that had of course been commented on by other archaeologists from around the world, people like Foley, for instance, Ebert. But at the time, in the 80s, there was a bit of concern about the ability of archaeologists just to look at the extent of exposures that the surface record presented. And I've picked out an article. This is from 1987, Jim O'Connell. It's quite a well-known one, I guess, and it really expressed both the potential for looking at these big surface areas, but also the difficulties that understanding, or really being able to record such extensive areas and the understandings that this might provide. But, I guess really even as Jim was perhaps writing this article, technologies were becoming available that would allow us the freedom, and here I'm going back to that Apple Mac ad, the freedom to look at areas that were just orders of magnitude bigger than those that had been successfully looked at before. And I guess I want to kind of illustrate that. This is a air photo of Rutherfords Creek, and all those sort of white dots there are those scords that I mentioned. Those are kind of eroded areas. And what we did back in the 90s, or back in the early 2000s rather, is to map the location of all of those scords right up and down this creek line. It's about 13 kilometres or so from the lake entry there. You can see Prairie Lake on the bottom right, and all the way up into the headwaters of the creek. We literally mapped hundreds and hundreds of these scords, and then picked a random sample, which I'll come back to a little bit, to analyse all the artefacts that were exposed on these scords. I guess this ability to look at big space is really the first aspect of freedom that was mentioned in that ad that I want to talk about. Suddenly we had the freedom to expand, and I guess I'll leave you all to conjure up the dystopian world that this freedom dispelled. Oh dear, I wonder what that's doing in a CAA talk. Perhaps we should move rapidly forward. So, from really the 90s, but certainly into the 2000s, we had the ability to use portable technologies to analyse really big space and thousands of artefacts. And there were two components to this. There was certainly the portability of the technology, but also there was, I guess, the theoretical concepts that made this really important. I've mentioned Jim McConnell, but I also need to pay tribute to the gentleman on the right there, Mr. Badger Bates. Mr. Bates is a Barkindji Aboriginal man, and way back in the early 90s when I was first thinking of working in Western New South Wales, I talked to Badger really about the possibility of working on his people's country. And he gave me some really, really good advice. He said, Simon, archaeologists have come out onto my country before, and you've picked up artefacts and you've taken them away. I don't want you to do that. And I thought, wow, that's an interesting challenge. I wonder if we could analyse the material in place rather than remove it. And indeed, that's exactly what we did. We adapted digital technologies to enable us to pick artefacts up, analyse them and replace them. And we did that for tens of thousands of artefacts. And you can see Matt Douglas now, Dr. Matt Douglas, of course, analysing some of those artefacts using portable technologies on a scord in Rutherfords Creek. We sampled about 5% of the scords that I showed you in the previous picture. That number's about 93, measuring 25,000 artefacts, roughly 20 or so, perhaps a few more attributes per artefact. Recreating a big spatial data set, we located every one of those artefacts in 3 dimensions using total stations, locked them into a GIS, which was our database. So I guess what we had was the ability the freedom, I guess, to create these large data sets. If you read the literature, there is, I guess, concern around just creating these data sets, and I want to really illustrate the theory that was behind it in a minute. But I also want to comment a little bit about some concerns around using off-the-shelf digital technologies and how these might constrain us. And, I've never really seen technology, off-the-shelf technology or technology that programs and things that we wrote really as constraining at all. And that's because the contexts in which we were using technology were so different. We were going out and recording these artifacts over such huge areas using technology that was never really designed for that purpose at all. And I think we need to be really careful to not just think of off-the-shelf technology as the box that indeed comes with whatever technology we're using, but also things like workflows. For instance, you can see Rebecca Phillips here in the slide, analysing artefacts, picking them up, putting them down again, as Badger asked us to do. But that whole workflow was really integral to understanding the use of technology, and I think really something that for me means that off-the-shelf doesn't really apply. I also want to comment on how we were looking at the archaeology in open sites, on what we call surface sites, and the importance that had for us in terms of looking at context. You can see on the slide my colleague Patricia Fanning, as Trish often commented, she was a geomorphologist, not an archaeologist. She really told us repeatedly that we were not looking at artifacts at all. We were looking at clasts, and it was the distribution of the clasts that we should worry about. Trish, I guess, brought to us a real concern for the geomorphic context of the material that we're looking at. And of course, a whole bunch of colleagues from around the world have pointed out that surface sites are prone to erosion and deposition, and we spent a lot of time thinking about those processes and the significance of those. There's an equal number of colleagues, of course, who have also pointed out that buried sites are also prone to a whole lot of geomorphic processes. But I guess looking at surface material really made us concerned about context. It was kind of a key. Technology brought with us freedom to look at those contexts over huge surface areas, but I guess it also brought the ability to think in somewhat revolutionary ways, and Trish was a key part of that. We mapped out, for example, the location of all the little kind of rill systems, bunches of vegetation, soil areas around those exposures, those scalds that I talked about. You can see an early kind of inset map there. We did all of that with a manual total station, all that focusing. Just imagine, right? Fortunately, technology has moved on. Another key aspect for me of revolution was intellectual. On the Australian project, I think we completed 6 PhDs. You can see people that were involved in writing all those PhDs. We had other PhDs that were completed on projects that used very similar sorts of technology in Egypt and indeed in New Zealand. You can see Mac Douglas, Trudy Dolman, Ben Davies, Josh, of course, who's running this conference, Trish again, Justin Shiner, Rebecca Phillips there, Alex Jorgensen, who is the most recent of the PhDs, and Tessa Bryant. All of those people really working on either Australian material or similar sorts of material, contributing to the revolution in our understanding. Now, I want to pick up on some material that Ben Davies on the top row there and I have been working on. We published a paper a couple of years ago. I'll run through a little bit of the results of those. But to kind of get us in the mood for revolution, I just want to step out a little bit and look at another little video clip.
Do not try and bend the spoon. That's impossible. Instead, only try to realize the truth.
What truth?
There is no spoon.
There is no spoon?
Then you'll see that it is not the spoon that bends, it is only yourself.
The Oracle will see you now.
The clip, of course, comes from the 1999 Warner Brothers film The Matrix, directed by Lana and Nadia Wachowski. And in it, you'll remember that Neo is about to see the Oracle. He's presented with a glimpse, really, of how to understand the functioning of the matrix. You can't look at the object, you have to understand the wider computer context, I guess, because it's written in a whole computer world. Now, for archaeology, the analogy, of course, is that we have to stop focusing on the spoon as a particular object, or indeed how the spoon or artifacts as objects functioned or how they were manufactured, and instead look at the context around which, in which I guess these objects appear. And you can understand that looking at the context in that way outside the object is indeed rather revolutionary. Consider, for example, the way that most archaeologists looking at the distribution of materials through a landscape think about settlement patterns, indeed settlement systems, objects that are concentrated together because they represent activities that are concentrated together. Those represent sites, the equivalent of particularly functioning locations that we find, for instance, in ethnographic accounts of hunter-gatherers moving through a landscape. Often people use categories of sites that Lou Binford defined in his ethnoarchaeological work. And I guess the revolution that we pushed, all those PhDs that I just mentioned, was to, like Neo, learn to look beyond the individual object, beyond the spoon. And I want to illustrate just a little bit how we achieved that, going back to our New South Wales data. You can see here a picture on the right of what we call a heat retainer hearth. These are places in the landscape where Aboriginal people lit fires. They used rocks, stone sometimes as heat retainer, other times clay balls, termite nest fragments and things. And they created ovens, in effect, that where food was placed on top of these stones, probably covered and cooked. And indeed, when we look at the archaeological remains of these, we find these beginning to erode in many areas up and down places like Rutherfords Creek. So we can map their location, and we did this, finding hundreds and hundreds of them exposed up that 13-kilometre creek. You can see on the left there, those little back dots on the creek kind of shape. Each one of those represents hearths. So we dated a number of these, got permission to excavate them, and found ages both with radiocarbon and OSL techniques. And I guess the interesting thing about just the presence of these, of so many hearths and indeed their ages, is that they kind of represent an archaeological pattern that colleagues working in the Australian archaeological record have really characterised in a number of different ways. If we go back to an older literature here, I'm thinking of Richard Gould, for instance, Harry Allen to a degree, people saw the distribution of archaeological remains like these hearths, but indeed also concentrations of stone artefacts, as representing something that, in Gould's terms, was a kind of desert culture, of quite a conservative culture. In more recent work, we see people saying, well, if you look at the distribution of these artifacts, they seem to concentrate in time, more with many more examples in the recent parts, the late parts of the Holocene, last few thousand years. And perhaps this represents, because we see increases in density of these artifacts, these represent more sedentism, people spending longer in particular places. People have tried to correlate it. Colleagues have correlated this with ENSO changes, population increases, changes in resource extraction and social complexity. And you see I've illustrated one of Ali Munim's articles here, and really because these notions have been expanded to the entire continent. Perhaps that we see forms of changes in society that we can see right across Australia, linked with things like population increases. So what we did in our New South Wales research was really begin to think about how we might test these ideas. And I want to share with you just some of the results. This is really comes from a paper that Ben Davies and I published a few years ago, looking at some of the ways that we might test these particular ideas. And I hope what it illustrates is a little bit of the revolution that comes out. Now, what I've got there is just a regression graphic that Ben produced, looking at the age from those hearths that we talked about, and the density of artifacts that we find on those scalds, those kind of eroded areas that we mapped and we analysed all the artifacts on. and looking at the relationship between age and density. Now, there's not a whole lot of points there, but for the ones that we have, you can see there's actually pretty strong regression relationship between age and density, such that the densest areas, we can call them sites if you like, but those schools, the densest schools, tend to have the oldest hearths, while the least dense schools have the more recent hearths, and that's a pretty strong relationship. Now you'll see that I've also got a formula up there. Many of you will recognise that's just Michael Schiffer's discard equation, which relates things like use life, artefact number, duration of occupation to artefact density. So in a way, really, that graph on the right is just a restatement of Schiffer's kind of discard equation, but it doesn't make us think a little bit about the relationship between age and density of artefacts, and perhaps investigate density a little bit more. So on the next graph, what I've done is to plot the density of not just those schools where we have both artefacts and dated hearths, but indeed all those 93 schools that where we recorded all those 25,000 artefacts. So what Ben did in the paper really is to look at log density, you can see on the x-axis, and just number of material of artifact types. So we're looking at density and perhaps diversity. And what we get again is a pretty good linear relationship, such that the densest schools also seem to have the largest range of artifact types. Now we could interpret this in a couple of ways. One way is that indeed this represents that kind of pattern that archaeologists around Australia have seen, suggesting more intensive occupation, and that's, as I said, been linked to population changes in the nature of resource exploitation, linked to changes in climate and things. But there's another way that we can interpret that, and simply that through chance, if you visit places often over a period of time, those places that for one reason or another have seen multiple occupations, that will quite probably increase the number of artifact types that are deposited. So we've got a couple of ways that we could read that graph there, looking at log density versus number of artifact types, either intensification or indeed just many more occupations in some schools compared to others. So one way to kind of differentiate between these two explanations is to go back and think about what Schiffer's discard equation represented. When it was originally created, of course, really was it kind of assumed that people were staying in one place. As you made artifacts, you used those artifacts and you discarded those artifacts in one place. But we know, of course, that really probably isn't correct. And many instances, ethnographic instances, but also now increasing archaeological evidence suggests that people who occupied places in the past did so. They deposited some artifacts, but they moved others away and indeed brought some in. So this notion of all the manufacture, use and discard happening in one place probably isn't correct. So some of those PhD students that I mentioned before, Rebecca Phillips, Matt Douglas, and indeed Ben Davies, really looked at a technique that my old mentor Harold Dibble had written about in the 2000s to look at how we might measure artifact movement. And this is, of course, the Cortex Ratio. We've talked a whole bunch about the Cortex Ratio, both in publications and in various talks around the place. So I won't go into it in a whole lot of detail, but it uses the, one could think about it as a kind of apple analogy. If we think of an apple, the analogy, of course, is with a cortical piece of stone, a cobble, that's going to be flaked. We can estimate the size of apples or the size of cortical stone. If we flake this stone, I guess cut the apple into segments, we remove or indeed add pieces of those segments of apple or indeed cortical flakes to an assemblage, we can compare the amount of cortex, the surface area that we see archaeologically, with the amount expected. And you can see that in the diagram there, the kind of wireframe, theoretical apple, the amount of cortex that we expect, and the apple on the top there representing the amount of cortex that we measure empirically. In that equation, all the flaking goes on in one place, so the amount of surface area, the cortex expected, equals the amount that we find empirically. But you can imagine if we added flakes, that ratio would increase beyond 1, and indeed if we remove flakes, it would decrease below 1. And so we used the cortex ratio as a measure of kind of mobility, looking at the value of that ratio, both within individual scalds, those eroded areas that we recorded, and indeed across the entire valley. If we calculate the cortex ratio for the entire valley, that is all those 25,000 artifacts that we recorded in Rutherfords Creek, the result is a ratio of about 0.53, with quite a bit of variance. The standard deviation is about 0.22. What does that 0.53 mean? Remember, if the ratio falls below 1, that means that there is cortex, surface area of the cobble, missing. That suggests that quite a lot of material was indeed moved out of those scalds and not returned into the valley. Otherwise, of course, the overall ratio would come back towards 1. So what Ben did is to look at those 93 scalds and plot the graph that you see on the right. On the x-axis, you see we have log density, and the cortex ratio is on the y-axis. And some very interesting, this is a very interesting graph when you think about the significance. I just want you to remember the little graph that I've got on the left there. That graph showed minimum age from the HARs that we dated against the log density. And there's a pretty good linear relationship such that high density scalds are older, more recent scalds are younger. So if we apply that result to the graph on the right, you can see log density there. We've got a regression line running through looking at the values of the cortex ratio. And while that regression line is a little bit negative, it's actually, the regression equation shows there's not a lot of power in that relationship. Basically, there isn't a whole lot of difference between the cortex ratios in the less dense to the left and the high dense to the right scalds. And remember, the less dense ones are relatively younger and the high density ones are relatively older. So that's a pretty interesting result, because it suggests, as I've put down in the little text at the bottom there, low density areas pretty much look like high density areas. And because of the relationship with time, therefore short duration results kind of look like long duration results, which is not what we expect if we are thinking that high density areas represent more occupation in the kind of an intensive occupation scenario. What it suggests is that we really have quite a lot of regularity across all those scalds, except for one thing, and I want to kind of emphasize that. If you look to the left of the graph, those low density cortex ratios really quite variable. Some are really high, right? Actually above 1, suggesting material's been added. Some are quite low, below 1, suggesting material's been removed. But as we move through density and therefore through time, what happens to that variability is it actually reduces. It becomes a lot more regular. So I guess the revolution for us suggested that high density sites are not really different to low density sites. And indeed, there is a reduction in variability. The pattern that we see becomes more regular in high density sites. So I wonder what that kind of might mean. And here I guess I come back to the combination really of freedom and revolution that Mac ad suggested. You know, the narrative models, the that I talked about that kind of dominate a lot of the interpretation of Australian archaeology. So here I want to come back to really talk about the freedom and revolution that the Apple Mac ad suggested. You know, the narrative models that really dominate, I guess, a lot of thought about the sort of archaeology that we found in Western New South Wales really suggest there's quite substantial shifts in the composition of archaeological sites, right? And they really focus perhaps on those high density ones as evidence of shifts in, as I said, social organisation reactions to population increase, resource changes and things. But, you know, because we looked at the context of a whole valley, we had the freedom to look not only at those high density areas, but also at the low density areas. We're really, really concerned about context. And we came in really not with a whole lot of models of how we thought hunter-gatherers acted, but we concentrated, following people like Trish Fanning, really on understanding the context of the artefacts. We weren't really interested in the function of the spoons or indeed the way that those spoons were made. Digital technologies provided both the freedom to look in that way, but also the revolution, I guess, in the nature of our interpretations. And that has led to quite a different result to the ones that we really expected. We understand that high density and low density sites are really on a continuum, and there's no particular reason to look at a different functional explanation for those high density sites. So I guess for me, digital technology provided both the freedom to look at an archaeological record in a different way, but it really had to be linked to create revolution with a lot of not only technologically heavy archaeological method, but intellectually heavy theory. And here I really look at those PhD students who worked on that project. The result, I think, really is revolutionary. So I don't have a lot of concern about the application of digital technologies being only empirical. So to finish off, I want to use a little vignette from one of Sean Connery's movies, really to kind of, I guess, illustrate the revolution that I'm talking about.
I grew up around here. My grandfather took me to fish off that island right over there.
There is one question you haven't asked me yet. Why?
Well, I figured you would tell me when you were ready.
Now, there are those who believe we should attack the United States first, settle everything in one moment. Red October was built for that purpose.
When the dust settles from this, there's going to be hell to pay in Moscow.
Perhaps, maybe some good will come from it. A little revolution now and then is a healthy thing, don't you think?
Thank you so much for listening, and thanks to Josh for the opportunity to talk to you. I've really enjoyed it. Kia ora.